Okay, so hopefully the very last part of ratio test. I want to ratio test another series. Okay, and for the sum of x minus 3 to the n over n, and it's going to go from 1 to infinity, I want to find the radius of convergence. Now this time I'm not asking you for both the radius and the interval, and you will see why in a few minutes. Okay, so now that I presented the fact that some of our series are geometric, is this a geometric series? And remember that it's geometric if n is only showing up in the exponent. And the answer to this, of course, is no, it's not geometric because I have an n as a base in the denominator. Okay, so if it's not geometric, I'm going to have to do a full ratio test. Okay, so I need the limit as n approaches infinity of the absolute value of the ratio of two consecutive terms. I want you to go ahead and set up your limit, pause, and come back to me. Okay, and when you have quotients, this is what your limit should look like. When you have quotients, it's usually such a disaster that I very often skip to the next step, and it's fine if you want to do that too. Instead of having a fraction divided by a fraction, you can automatically jump to having the first fraction multiplied by the reciprocal of the second. So I would normally just jump to the following limit. Okay, this looks so much better. So the limit as n approaches infinity, absolute value of x minus 3 to the n plus 1 divided by n plus 1. That's my a sub n plus 1. And I'm going to, instead of dividing by a sub n, I'm going to multiply by the reciprocal of a sub n, which is n over x minus 3 to the n. Okay, remember that those absolute values are needed on your x terms, but the limit is not. And the absolute values are not needed on your n terms, but the limit is. So make that separation, try to simplify this, pause, and come back to me. Okay, so x minus 3 to the n plus 1 divided by x minus 3 to the n, the bases are the same. If I subtract exponents, I get a 1 for an exponent. So I just have an x minus 3 to the first power. I need absolute values on that, but I could pull it out of my limit. So I have absolute value of x minus 3, and then times the limit as n approaches infinity of whatever's remaining, which cannot be simplified. So n over n plus 1, that part does not need absolute value bars because n is always positive, and it's getting more and more and more positive. Okay, for this part of the limit, okay, I expect at this point that you know how to take this limit. You do not need to show me work for this limit. You either need to L'Hopital it or to use an end behavior model for it. And however you do that, this limit should give you 1. So either L'Hopital or end behavior model, you get 1 for that, which means that this limit, if you do 1 times absolute value of x minus 3, you get absolute value of x minus 3. Okay, so ratio test says that my result has to be less than 1 in order to be convergent, so I need to have this value to be less than 1. Okay, so I have absolute value of x minus 3 has to be less than 1. I'm going to have to solve this inequality. And I just want to remark real quickly that for my radius of convergence, I'm actually set to go right here. Okay, once I told you guys that when you have your inequality and there's no coefficient on the x, so there's nothing, I have x minus 3, but I'm not multiplying or dividing by anything. Okay, that means that this is my radius of convergence. So I can right now say that the radius of convergence is 1. Okay, let's talk about why we can't find the interval of convergence right now. Okay, so let me solve that inequality. To have absolute value of x minus 3 less than 1, x minus 3 has to range between negative 1 and 1, and if I get rid of that 3, I end up with the inequality that x has to be between 2 and 4. Okay, I just want to, again, just focus on the fact that this series, where is it centered? It's centered at x equals 3. I see this interval. I'm going from 2 to 4 on the x-axis, so from 2 to 4. That interval is centered at 3. Okay, the hug is uniform on either side of the kiss. Okay, so just to remark on that. Now, the question on the interval of convergence here is, what's going on at these endpoints? Okay, what kind of hug is this? Is it going just up until 2 or 4, but not 2 and 4, but not touching at 2 and 4? So is my interval like this, not including 2 or 4, like it would be if it was a geometric series? Would I include both endpoints? Okay. I always equate this, I know, back to the hug analogy, that this first interval is a hug that you kind of don't really want to touch the person, but you have to hug them, and this is like a serious, like, well-meaning hug. Or is it like a well-meant hug, but you're holding a cup of water in one hand? Okay, so including 2, but not including 4, or not including 2, and including 4. Okay, so each of these could be possible intervals of convergence, and what we're going to see right now is that I'm not going to be able to tell what's happening at those endpoints until we cover the next section when we start testing series of constants again. Okay, so right now I can say that my interval goes from 2 to 4, but I can't say, is it exclusive? Is it inclusive? Is it partially inclusive? Okay, including one endpoint but not the other. I can't pinpoint that right now, so that's why we can't determine an actual interval of convergence. Okay, so I just want to recap a little bit. Okay, this is from our first video. We talked about different possibilities for the radius of convergence and the interval of convergence. I want to talk about what the ratio test will yield in each of those cases. So if my radius of convergence is infinity and the interval of convergence is from negative infinity to infinity, that means that it's convergent for all values of x. Okay, that means that when I ratio test, I'm going to need to get something that's always less than 1. So what kind of number did I see in my ratio test? That was like with sine x. I got think about it, but I got a 0 for my ratio test. Okay, and if I get a 0 for the ratio test, then that limit of 0 is always less than 1, which means that I'm going to converge for all values of x, and my interval of convergence will go from negative infinity to infinity. The second case was when r was 0, and the interval of convergence only contained one point, and that point was the center of the series, the kiss, okay, because a series approximation will, or a polynomial approximation will always agree with the function at the kiss at the very least. And if that's the case, I need to get a limit from ratio test that's always bigger than 1, except in that one situation at the center. And my ratio test will then yield infinity. Okay, because infinity is always bigger than 1, except if I multiply it by a 0, which means plug in the center of the series. The last case is like that last problem like we just did, where we get a radius equaling some number. The interval of convergence is going to be to be determined, and the reason it's to be determined is because I cannot pinpoint the convergence at the endpoints or not, but we can say that the interval will go from, it's always centered at the center, and I'm going to be going, I can add on that number to find the upper bound of the interval. I can subtract the number that I get for my radius of convergence. The number that I'm using is this number here. And it's just what's going on at the endpoints. Is it exclusive? Is it inclusive? Is it partially inclusive? Okay, that's what I'm not going to know about. Okay, what will the ratio test yield? The ratio test is going to give us, just like that last example, it's going to give me something in terms of x. Okay, and that's something in terms of x. It's like when I have absolute value of x minus 3 has to be less than 1, or absolute value of 2x is less than 1, or absolute value of 2x plus 4 is less than 1, or something like that. Okay, so something in terms of x that I'm solving that inequality. But if I get something in terms of x, then my radius of convergence will have some value to it, and my interval of convergence will be numerical with, I just don't know what's going on with the actual interval as of right now, but we will come back to it and figure it out. Okay, one little note that I want to make is that I want you to watch out for geometric series. Okay, I want you to watch out for geometric series. We know a series is geometric if n is only in the exponent, because with our geometric series, we don't have to ratio test. All we need is to show that absolute value of r has to be less than 1, okay, and r is going to be anything that has an exponent to it. Okay, so hopefully you've taken good notes. I'm going to stop. I'm not going to do any more examples because I think you guys have had enough, and we're going to hash this out in class together on Monday.